Good evening, folks. Welcome back. This is Mike coming at you with yet another video on Foundations of Math 2. In this video and the following video, we are going to compare two types of ways in which interest can be calculated. Simple interest versus compound interest. This can be interest that you get on your savings account, or it could be interest on a loan that you took out. So before we get into each of these methods and the calculations, let's just familiarize ourselves with some terms and some notation that we use. The principal. The principal is the amount of money that we borrowed or that we deposited into our savings account to start off with. If we, say, took out a loan of $10,000, then the principal would be $10,000. If we deposited $20,000 into a savings account, then the principal in that case would be $20,000. R is our rate. It's the percent of the principal that's paid to the bank for having loaned money from them, or it's what's paid to you from the bank for depositing your money into their savings account. The rate here, it is typically stated as the annual rate. So this is what rate you get for the whole year, unless it's specified in the question that it's something else. And also, we always use the rate as a decimal, not as a percentage. So you have to convert the given percentage to a decimal and then use it in that form. We have the time or the term given by T. It's the length of time that the money is borrowed or that it is deposited. Time we typically measure in years. Interest is the fee that's charged for the use of the cash. Either the bank charges you this interest if you're borrowing money from them, or the interest is, in a sense, what you charge the bank for allowing them to use your money in some sense to do their daily transactions, which is really what happens when you put your money into a savings account. Yes, it's your money, but you're, in essence, letting the bank use it so that they can make cash back for other folks and do all these other things that they would need money for. And then the future value, which we typically symbolize by capital A. This is the amount of the loan, or what you put in, plus the interest you paid out or the interest that you get. So now the actual formulas. The formulas for simple interest and future value using simple interest are very basic. They're very straightforward. The amount of simple interest, I, is simply 8 times your time. How much do you borrow, say, times the rate at which you're borrowing, times how long you borrowed it for. And then, since the future value was the amount of your loan, aka your principal, plus the interest, I, A is P plus I, or P plus P times PRT, or P times 1 plus R times T. So here's a couple quick sample problems here. You deposit $7,000 into a savings account with annual interest rate of 1%, and the money sits there for 4 years. How much interest, simple interest, have you made, and what is the balance of your account going to be after those 4 years? So first, if we just calculate the interest, it's principal, in this case, $7,000, times my rate. The annual interest rate is 1%, but as we said, we use this as a decimal, So 1% as a decimal is 0.01 times my time period of 4 years. You can now plug into, if you do 7,000 times 0.01 times 4, you will get $280. And that's how much interest you would get for those 4 years. We also wanted to know what the balance of our savings account will be after the 4 years. That's another way of asking what is our future value. So A is the principal, how much we deposited, 7,000, plus the interest I got over that time period. We just calculated the interest that we get over that time period, $280. So add those up, and our account balance after 4 years would be $7,280. This is, of course, assuming that we don't add any other money in and we don't take any money out. So that's just a very basic, straightforward application of these formulas here. This one, a little bit different, kind of. Your friend tells you he got $1,000 in interest for depositing money into a savings account with 3% annual interest for 10 years. How much money did he initially deposit into this savings account? So we know the annual interest rate. There's that 3%. We know for how long. We know that time. We know how much interest he got, but we don't know how much money he put in at the start. Well, if we look at our formulas, I know I know R, I know T. I can then solve for P. So my interest, $1,000, is going to equal my principal, whatever that is, times the rate, 3%, times time, times 10 years. Or 1,000 is going to equal 0.03 times 10 times P. It's going to equal 0.3P. And 1,000 equals 0.3P. I can divide both sides by 0.3. And I can use this to figure out how much money was put in at the beginning. So if you pull out your calculators and do 1,000 divided by 0.3, you find that P was equal to $3,333.33. So a little bit of a different application of the formula, but still nothing too complicated out there in the world, nothing super crazy. As a quick side note, if you find a bank that will give you an annual interest rate of 3% on your savings, definitely take it, because for most places nowadays, annual interest rates are incredibly low. They're significantly less than 1%. Sometimes the time period which we have our loan or we have the money inside of our savings, perhaps it's not quite 1 full year yet. So here's a sample problem where we can see something like that. So how much interest would you owe on a $20,000 loan that has a 5% annual rate of interest for 4 months? Again, we're calculating interest. We know that I is equal to PRT, principal times rate times time. We know the principal, or the amount of our loan, is $20,000, times the rate, 5%, use it as a decimal, 0.05. And now time. Time we usually use in years, but this is saying 4 months. Well, what fraction of a year is 4 months? 12 months in a whole year, 4 over 12, or 1/3. So if we do 20,000 times 0.05 times 1/3, we're going to get $333.33. Now, obviously, if you did use your calculator, you'd see that we get 333.333333, so on and so forth. But because we're working with money, we always round to 2 decimal places because we can only go to pennies. But nothing really new that's going on in this practice problem here. The only thing that's slightly different is that here we were given a time frame in terms of months. You could encounter something less than 1 year, so you just have to figure out what fraction of a whole year that thing is. Now, what is sort of a common practice that banks will use to figure out the interest that you owe on a loan or a mortgage or something like that? Although there are 365 days in a year, many lenders will use what's known as the banker's rule, where they actually count the number of days in a year as 360. And this has a bit of an interesting effect on the amount of interest that you would owe. So we're going to see what exactly that effect is. So we have a $10,000 loan, 5% annual interest, and this is for 80 days. We're going to compare what percentage, or I should say what fraction of a year we have using 365 days versus 360. So we're going to calculate the interest first by doing this with 365 days in a year, and then we're going to recalculate the interest with using 360 days in a year. So using here, my interest, principal, 10,000, times my rate, used again as a decimal, 0.05, times time. Now, time here, 80 days is what fraction of a year? Well, we're counting 80 days. There's 365 days in a whole year. So if we were to take out our calculator, if we do 80 divided by 365, you see we get kind of an ugly looking decimal, 0.219178, something like that. Take that, multiply it by 0.05, and then multiply that by 10,000. And then round that value to 2 decimal places, you get $109.59. So there we go. This is what the interest would be if we're counting 365 days in 1 year. Let's now redo this using the banker's rule. We still have the same principal. We still have the same annual rate of interest. What's going to change now is our time. Interest, still going to be 10,000. Rate, still going to be 0.05. And now the time, it's still 80 days, but now we're doing this out of 360 days, not 365. So pull out your calculator. And if you kick it off by doing the 80 divided by 360, you're going to get 0.2222 repeating on. Take that, multiply it by 0.05, and multiply that by 10,000. You are going to get, rounded to 2 decimal places, $111.11. So we can see here, and this is generally true, that using the banker's rule, there's a reason lenders use this rule. It's so that they can charge you more interest, and for them, interest is just the money that they take in, and that's how they make money on the loans that you get from them. So using the banker's rule is a handy little thing for them because it makes them more money. It forces you to pay more. Now, comparing these two numbers, there's a very, very small difference. It's $1.52. But think about significantly larger loans. $100,000 $200,000, 5% interest, 4 to 5% somewhere in there, and then picture, say it's over several years. Pretend you're thinking of a mortgage loan on your house. A $200,000 mortgage loan with 4.5% interest for 30 years. That's going to get you a lot of interest. That's going to make the banks a lot of money. So there's a reason that they use the banker's rule. It's so they can make more money. In some cases with loans, the interest on a loan can be paid up front by deducting the interest from the amount of money that the bank gives you. This is what's known as a discounted loan. And these things are very sneaky. They're very deceptive because the interest rate that you're quoted at when you get the loan is actually lower than the interest rate that you're actually paying on that loan. I'll be honest, I'm not sure how often these things are still used now, but given that it's kind of a sneaky practice and it's sort of out there that this is a sneaky practice, I'd be willing to wager that overall you're not going to see these used that much, if at all. So as a nice close to this video and a nice little lead into the next one, if you look at what we're really doing when we calculate the simple interest, simple interest is interest calculated on the amount of money that you put in at the start, regardless of how long it sat there. Whether you put the money in a month ago or you put in the money 10 years beforehand, the amount of money you get in terms of interest, say per year, is only based on what you put in at the very start. Compound interest differs. Compound interest is calculated based on the balance at the previous time period in which you calculated the interest. It could be every year, it could be every 3 months, it could be every half a year, it could be every month. We're going to go more into this in the next video, but we're going to see that it's better to have compound interest. And we're going to do a sample problem to see this. It's better because we get more interest this way than if we found the simple interest. So we'll end our first video there. As I said, in our next video, we are going to take a look at compound interest, how that's calculated, and some other related concepts and things tied in with compound interest. Guys, if you have any questions or comments, please be sure to reach out to me. call, text, email, carrier pigeons, rocks through my window, signs in the stars up in the sky. Whatever you have to do, until the next video, take it easy, guys.